Hello, everyone. How are you guys doing today? Tired? No answers. Okay, so if you noticed, I actually posted the review sheet on Brightspace. The review sheet has problem set from 4.5 to 6.2. So I don't know how much we can finish before the exam, but if we can cover more, I'll think about more. But for now, my plan is to finish up to 6.2 and then give you the exam based on that. Plus, you have so many exponent rules. So I put them together. Make sure you remember them, understand them. In the exam, I'm going to ask around 35 questions on these rules. Okay. Any question, comments? Oh, and your exam one is next week, Friday, on 7th, March 7th, next week, Friday. Any question? Comments? Concern? Complain? Nothing yet. I'm so sleepy. So, I'm actually gonna start with exponent rules. The rules you learned in our last class, I'm going to review them first. And then we are going to go to the new stuff. What is that? Do you remember your rules from last class? Most of them you do. Okay, let's see. I'm going to give you 2 minutes to copy this. Ready? Lindra, the first one. Y, Z, Q. And what happens to the X and Z? Okay, so you're distributing the power to everything on the top and on the bottom. Good job. And we can go one more because we know what is 5 cubed, right? 5 times 5 times 5. 125. And then X cube, Y cube, Z cube. We have no idea what they are. Okay, Nick, 3 square whole thing to the 4th power. 3 to the 8, perfect. So when you have more powers but one base, we keep the base, but we actually multiply the powers. And this time I'm going to leave it alone because 3 to the 8 is a big number. I don't know what is that. Let me write nicely, 8. Gavin, x to the 20 times x to the 5. Good job. When you multiply the bases, we add the powers. So it's 20 plus 5. That gives us 25. Muhammad, the next one. So y is bigger. We keep the bigger y on the top and we subtract the smaller part from the denominator. On the other hand, x is bigger on the denominator. So we keep the big x, but we subtract the smaller part from the top. And that's how he got the perfect answer. Y to the 13 and Z to the 14. Sorry, X to the 14. Let me read. Any questions so far? So do you remember all these rules you learned in our last class? Okay, Robert, 4xy whole thing to the power 0. Perfect. The rule says anything that is as long as not 0, any non-zero base to the power 0 is always 1. So we can have 4xy. We can have million to the 0. We can have xyz, everything to the 0. It doesn't matter. As long as we don't have 0 on the base, the answer is always 1. Eric, would you like to try the next one? -1 to the 25 power. Positive or negative? 25 is odd number or even number? 25 is odd. So if you multiply negative odd many times, like 3 times, do you get a negative back or do you get a positive back? Negative. So -1 with the odd power gives you -1 back. Michaela, would you like to try the next one? -1 to the 500 power. 500, is it an odd number or even number? Think about, so we have 0, right? Think about a number that has a 0 in the last digit, like 10. Is 10 odd or even? If you can divide any number into half pieces, that means it's an even. Can you divide 10 into 2 pieces evenly? What are these? 5 and 5 gives you 10, right? So yes, you can divide 10 into two equal pieces. So any number you can divide into two equal pieces, that means that's even. So 500, is it even or odd? Even. So if you multiply -1 even times, even like 2, if you multiply -1 twice, what do you get? -1 or +1? -1 times -1. +1. So just because you see 500 is a big number, you don't have to worry about the big number. Think about the concept. 500 is even. So if you multiply negative even times, it's supposed to get a positive number back. So this is actually +1. Katie, what is 0 to the power 0? Brianna? Nothing, but what is nothing? What expression we use for nothing?
Forgot.
Doesn't exist.
Yeah. This ain't no solution.
It doesn't exist. We have no idea what is 0 to the 0. Giselle, what is 0 to the -11 power? It doesn't exist. If you forget, no problem, convert the negative into positive power. So anytime you convert negative into positive powers, it becomes a fraction with the positive power. So we have 1/0, 100, 0, 11 times. If you multiply 0, 11 times, what do you get? Still 0. And now, can you divide 1 into 0 pieces? So the answer doesn't exist. So anytime you forget about negative rule, convert into positive rule and see what do you get. And lastly, Madison Orlando, would you like to try the last one? What is 0 to the 79 power? Okay, this time 79 is a real number, a whole number. So if you multiply 0 79 times, what do you get? 0. So when in a whole number, your life is easy because all you have to do is multiply the base how many times? So 79 is a whole number, no negative, nothing. Multiply that 79 times. Well, you can multiply a million times. Still, you're going to get 0 back.
Wait, why is 6 doesn't exist and why is 7 0? Like, why
The difference between 6 and 7 is 6 has a negative power. Negative power means it's a fraction. Fraction means if 0 is on the denominator. But we cannot divide anything by 0, so it doesn't exist. And positive power means you're multiplying your base that many times. So you're multiplying 0 79 times. You still get 0. Okay, Christina, would you like to try 1 to the 0? 1. Perfect. Catherine, 1 to the -30 power. Still 1. Great. 1 is the most generous one. It doesn't matter what power we give it, it still always gives us the same thing back. Maria, would you like to try next one? 1 to the 13 power. Still 1. Great. Anything to the 0 power, as long as the base is not 0, answer is always 1. So that's why we had a rule before. Anything not 0 to the power 0 is 1. Only when 0 gets the power 0, we have no idea what that is. Any other question? Okay, so these are the rules we learned previously. In our next class, we are going to learn more rules. Between last class and next class, we are going to learn something new. It's called polynomial. We're going to learn how to multiply polynomials, add them, subtract them. Now, polynomial is anything that has a whole number power, which is not negative. So whole number, positive power. All the variables must have whole number powers, which are positive. For example, this one, x to the 5 is a whole positive number. X squared, 2 is a whole positive number. So as long as all the powers are positive in whole number, we call them polynomial. But if you have a negative power, it's not a polynomial. Or if you have, let's say, fraction. If you have a fraction power, it's not a polynomial. Okay? So in order to be a polynomial, our condition is all the powers of the variable, they have to be a whole number and positive.
So they can't be negative numbers at all.
Or fraction. If they are negative, they are not polynomial, they're some type of, they're called rational. Decimal is like fraction. The condition says whole number positive. That's it, two conditions, whole and positive. Now, in a polynomial, we may have many, many terms. So in order to think about what type of polynomial we have, mathematician actually invented something cool. They said, well, it doesn't matter how many terms you have in a polynomial, you can ignore everything else except for one term. That one term is the term that has the highest power. The highest power of a polynomial is called the degree of the polynomial. For example, here, we have the power 4 and power 20. Which one is highest? 20. So the degree of this polynomial is 20. Degree means power. And power, especially the degree, means the highest power in the polynomial. Now, leading term. Leading term is the term that has that highest degree. So in which term we have the highest degree? The first term, the second term, or the third term? The first term, second term, or the third term? Second term. This term has the highest degree, right?
It has to have a variable. Like the x. Okay.
So whichever term has the highest power, we call them the leading term. So here our leading term is negative 3x to the 20. And now in this term, whatever number you have in front of your variable, that's called the leading coefficient. So what is our leading coefficient?
3.
Negative 3, including their sign. So why do we care? Well, we care because based on your sign, based on your highest degree, we can actually know what type of polynomial we have here. For example, the shape of this polynomial will be something like this. When both ends is going down and something is happening in the middle. Okay, so I have no idea what is the x-intercept or how many bump we have, how many things we have, no idea. The only thing I know is that we have y-intercept 7. Why? Because when x is 0, they get vanished. The constant is the y-intercept. And the two sides are going downward. How do I know? Because we have a polynomial that has a negative leading coefficient and even degree power. The details you're going to learn in your pre-health class. So in this class, I'm just introducing you to the concept, and then I'm turning to the addition and subtraction. So to add and subtract polynomial, we add and subtract their like terms. That's it. For example, here, we have 5y squared and then negative 11. 5y squared, negative 11, are they like term? They are not, right? Because they don't have the same variable. Like term means they have to have the same variable with the same power. 11 doesn't have any variable, so I cannot combine these two.
We combine it to 9.
We cannot combine to 9 because 9 doesn't have any y squared. We can combine 11 and 9. They are like term.
Yeah, that's what I meant, like 11 and 9.
Oh, you said combine to 9. So it's like, oh, combine these to 9.
No.
11 to 9, yes. They are like
You'll
terms.
combine 5 and 3.
5 and 3 because they both have y squared. Same variable, same degree. That's how we add and subtract. We look at the variable. If we have same variable at the same degree, they are like term. So you combine them. And when you combine, we actually keep our variable portion and combine only their coefficients. What is 5 minus 3? 2. And then you combine our 11 and 9. What is negative 11 plus 9?
Positive.
Positive 2. And that's it. Combining polynomial means combine like terms, Robert. Negative 2, Brianna, come on.
But aren't you adding now? Oh, yeah, you're right.
Negative 11, you're going positive 9, 2 minutes left on the next
Sorry.
one.
See, they're paying attention though.
Exactly, thank you. The next one you're going to by yourself. Let me just tell you what they're telling you. It says subtract that. Okay, we are subtracting this polynomial from the sum of these two polynomials. We know subtract means, right? Subtract means you're subtracting. But sum, what does sum mean? Adding. So they are telling us add these two polynomials and then subtract the top one from the sum. So you're subtracting 9y squared minus 2y minus 2 from the sum of the first two. 7y squared plus 1 plus 5y plus 8. So sum of these two means you're adding them, and then subtract means subtracting. So subtract these from them. And now go ahead. Add them, subtract them, combine like terms. And let me take that from this. Today is 225. Brianna Almonte here, Christina here, Catherine here, Jolene, Govan, absent. Madison Field, not here. Eric here, Abraham sick, Stephanie, not here. Leandra, go ahead.
They don't have the same exponent, but they still have the same variable. They still like to.
Robert here, Katie here, Kimelsia, not here. Maria here, Cindy's here. Michaela here, Madison Orlando here. Angie. Angie's not here. Mazabin, not here. Melbelis, not here. Giselle here. Mohammed here. Tahsin here. Gavin here. Brianna, Texas here. Carla here. Yvette here. Nick here. Danielle here. Hassan, not here. Melville is right. How come there are so many absent today? Many people are absent. Are you guys ready? Then check with your neighbor. Do you have the same answer? And then if you don't have the same answer, check which of you has the wrong answer. See, I love this sound, the talking, conversation. Tahsin, move closer to Mohammed, that group. And then check. Robert, check your answer with the people in front of you, Gavin and Nick.
Is it 2y to the second minus 7y?
Is it? Mohammed, what do you have? Check with them. And before that, we went about the estimate rules. And then we learned what is leading term, leading coefficient, polynomial degree. And then we did one example, subtraction, and now this is the second example. No, you're subtracting. Yeah. First you're adding, the second one you're subtracting.
That's what I did, but like I actually multiplied, got like 30 seconds.
Why did you multiply?
I'm not gonna ask.
No, I thought you meant like that. That's one.
What do you have to do? I have 2x squared minus 7y. 2y. I'm gonna be with that. How do you have to that one? Look. So basically, I had dropped this down. You can't add these to it. Drop this down. Okay. Then whatever. Then I.
So it's.
That's wrong. You're positive anytime you press question,
So everything here also all gonna turn positive. Okay, I got it.
this one is like
So it's gonna be positive, positive.
Minus 9. Oh,
Okay,
I see.
I go back in it.
It's right, everything's fine.
See how she put for right outside the 9. Multiply. Next line. Like. Okay, so basically. Yeah.
Yeah.
60 y for the second. 5 plus 2.
I got
y.
It's 16, 2y squared.
Negative 60. Isn't it negative?
It's two,
Oh, wait, this is positive. It's positive, yeah, it's 2. It's 2y. Yes.
What am I doing?
It's negative 2y.
Okay, this is.
I get it.
Yeah, but it's not.
Make some bright.
Exactly, wrong.
They, for the polynomial, the only polynomial. So they have.
I'm like, I can see.
You have to.
See, that's one of the reasons why I started like, no, you're not, I know. I did.
It's not even words, like, after.
Once you. Oh, no. That's positive 9 mice.
I mean, I failed. It's about one page, like, the one page that was literally a blue, no, she's. At least he's not. Yeah, like. I would do my thing just. That really gets me. It's like. I really have a whole class today, a whole different class.
Negative.
I even know crop.
Oh, wait, no. That's the next. You can all be all.
I think I do
Yeah, okay, you're right, you're right.
Yeah. I'm like, I think my time management is what we have. I literally made it 10 minutes before my class. And I did not turn it to, I didn't get. Oh my goodness, nice for this one. Today. I had a. I had 10 minutes to go. What class is your class? Mine starts at 9:50. Yeah, mine starts like. That's a long meeting. Yeah, class. Yeah. So bored. Yes. In the other building. Yeah. Yes. Oh my goodness. God, I needed 10 minutes before there. I just was like, is Yanni? I took some paper that I had like go. I'll keep my assistant back. See that? I don't know if she put mine because like to be honest, I should have really printing out. Like I didn't have to print it out. The first one they're only first. They're in the way from our side. I'm thinking. It's like I stood there like 3 minutes more there. And these are not the last. So I get my I go to the speaker. So then I have to wait for her.
So the mistake I noticed in most of the paper is that you actually forgot to distribute the negative. Anytime you subtract something, all the sign changes. So for addition, nothing changes, but for subtraction, we get negative 9y squared. And then it becomes positive 2y. And then positive 2. Only whatever you're subtracting, that changes sign. And whatever you add, they stay same. So 7y squared plus 1 plus 5y plus 8. Which most of you did not get correct. That's why answers are different from one another. Like, oh, what's going on? So then you combine like terms. We have y squared once, y squared twice. That means you need to collect all the y squared. We get negative 2y squared. And then we have 1. So for 1, we have plus 1, plus 8, and plus 2. So when you collect all of them, how much you have? 8 plus 1, 9. 9 plus 2, 11. And then lastly, we have, What? What happened? When you subtract, the sign changes. So 9y squared become negative, 2y become positive, plus 2 become positive. And that's how you add, Leandra. Never mind. Your mistake or my mistake? Which one? Go ahead, ask me. What happened?
No, I mean, like, you said practice some, I mean, the 9 minus some.
So subtract these from the sum. So these are the sum from that. You're subtracting this.
Because when you combine the 7y squared plus that, it's the one term minus the other, right? That's why I think everyone did it a little bit confused, but we did the sum first.
Okay, so what is the sum class is 7y squared plus 5y plus 9, right?
Yeah.
From the sum, you have the two things same, and 8 and 1 give you 9.
And then
Now from that, you subtract this.
Yeah.
But when you subtract these, you have to change your sign.
One, no, that's. We don't know.
Anytime you subtract anything that has more than one term, you must put parentheses. That's why I put the parentheses here.
I'm pretty sure we're getting 7y squared. Plus 5y plus 9 minus 9y squared minus 2y.
Right. And that's the wrong everyone did. Because when you subtract, you cannot just put minus this. You have to put minus parentheses and that. Because you're subtracting more than one. Giselle.
I think what she said, 7y squared plus 5y plus 9, subtracted by 9y squared minus 2y minus 2. Except the difference is that when you subtract a negative number, it becomes positive. So that's how I ended up getting negative 2y squared plus 7y plus 11. I didn't distribute the negative sign, instead I just subtracted.
Because you had the idea, when you subtract a minus, it becomes plus.
Yeah.
But they forgot that. That's the main problem. We forgot, guys. So the last thing, we have the y's. So we have 5y and 2y. That gives us a combination of 7y. And this is the final answer. Now you know you have to subtract, right? So go ahead to the next one, Maria. Huh? Because you're subtracting a minus 2y. When you subtract minus 2y, subtract minus 2y, we have double mating. I hope the next one will be easier for you because now you know how to subtract. And guess what? I'm going to ask one of these in the exam. And probably they will or 3 points, depending on how many powers I have. So here I have 3 different powers, so 3 points. If I give you 4 different powers, it will be 4 points. And your exam is next week, Friday. Second exam next week, Friday. And if you're late, I already posted the review sheet on Brightspace. 8x squared, and then what? How many x? Minus x, right? And then plus 9, right? Cool. Giselle, what do you have? Same thing? Catherine, no phone. Ready? Not yet. Okay, 1 more minute. This should be much easier because you already know how to do that. So when you add, nothing change. But when you subtract, what happens to the last term? What happens to the negative 4x squared? It turns into positive 4x squared. And what happens to the negative 17? Positive 17. So that was the hardest part, converting your sign. And now all you have to do is combine like terms. So what are the like terms? How many x squared you have? Total, how much you have? 8x squared. How many x term we have? When you combine, what do you get? Negative 1x. 1 is invisible, we didn't have to write it. And how many constant we have? When you combine, how much we have? Positive or negative? Positive. Perfect. See, it's much easier now. Any question? Yeah, but box method is easier when you do multiplication. Here is simply combining like terms. You can do that. You don't have to do box. You can simply write them below one another. 2x squared plus 2x squared plus 4x squared. So we have total 8x squared. And then we have plus 7x minus 8x. That gives us 1x. And then we have minus 9 plus 1 plus 17. 17 plus 1 is 18. 18 minus 9 is plus 9. If this is easier, you can do vertically instead of horizontally. Any question before we move on to the multiplication? No? Multiplication is very similar, but in multiplication, we use the exponent rules. So when you multiply number with the number, and you multiply variable with the variable. For example, here, we have 6 and 5, their number. So you multiply 6 times 5. And we have variable and cube and n to the 5. So we do n cubed times n to the 5. When you multiply numbers, we get number back. What is negative 6 times 5? Negative 30. And now we use the exponent rule. In multiplication of the bases, what do you do with the powers? Add them. So we get n to the 8. That's all you have to do. Multiply numbers with the numbers, variables with the variables, but for variables, you actually add the powers only by keeping the variable only once. And When you have one term, we call them monomial. So we are multiplying two monomials. We still get one monomial. In the next one, we have one monomial and you're multiplying one binomial. Binomial means our polynomial has two terms. So multiply a monomial with a binomial. And you already have some idea. How do you multiply this case? Good job. Distribute. So we do negative 4x times 9x to the 4 and negative 4x times the 7. So negative 4x times our 7. So distribute, and we do the exact same thing what we did on the left page. Multiply numbers, combine the for variable, add the powers. So what do we have in the first term?
It is 36. X to the 4.
X to the how many? You have 4 and you have 1 there. So how many total?
5.
5. So one variable, another variable, combining, give them 5 power.
So even though you're distributing and like you're multiplying, the exponents are still getting added.
Because we have the same variable x. This is not 4 times, this is 4x, negative 4x times that. So since it's an x, so it has 1 power, and the other x to the 4 has 4 power. So total we have 5 powers. So what is our next term? Negative 28x. And this time we only 1x, nothing else. I just bring it down. These are too easy, right? That's why this will not be in the exam. What will be in the exam is the next one. This you'll see in class exam, which is next week. Also, you are going to see this in the final. One of them will be in the final. So previously I gave you around 7 questions, and now we have 1 more for final exam. Make sure you collect all those final exam questions in one place. Write them down in one paper, one after another. And then all you have to do before final is study those questions, and you'll pass with a flying color. Question?
But like I'm distributing 4x minus 3 to
Each one of them. So here we have 2 methods. Either we do it just like that, distribute, or you can use one method called box method. Let me show you the box method first because it's easier for many people. So in the box method, you create a box. That's why it's called box method. So when you create a box, you write one polynomial in one side and other polynomial in the other side. So for example, this is too big, let me make it smaller. We have 4x and minus 3. This goes somewhere, either on the left or on the top, it doesn't matter. And then we have 6x squared. So that goes on the top. Then we have minus 5x. And then lastly, we have plus 2. And now all you have to do is multiply them and combine them. So let's multiply these two. What do you get?
X to the third.
24x to the third. And then you multiply the next one. negative 20, and then x to the second. And then you do the last one, plus or minus. Which one? Plus. So this is plus 4, and this is plus 2. That gives you plus 8, and our variable is alone, so 8x. And then you go to the other direction. You take negative 3, and you multiply with 6x squared. Negative 18x squared. Then you go to negative 3 with positive 15x. And lastly, negative 3 with 2, negative 6. So you multiplied all 2 and 3, 2 by 3. Now all you have to do is combine like terms. So the first thing we see is a cubic power, right? Do you see any other cubic power anywhere?
No.
So you leave it alone. 24x cubed. Then our next power is 2 power. So we have 20x squared, negative 18x squared, negative 20, negative 18. Do you see any other x squared? No. So you combine them. Negative 20 minus 18. Negative 38 x squared. And then our next term is x term. So 8x and 15x. 23 plus or minus? Plus. And lastly, what we did not use? Negative 6. That's it. This is called Bach's method. And I found it fascinating, like, ooh. I actually never used it. What I did, let me show you on the left page. Traditional method. You take one term from the left and multiply every term on the right. So 4x times 6x squared plus 4x times negative 5x plus 4x times 2. So take one term, multiply everything. And then since I don't have space, I'll do it in the next page. Next line. Then you take negative 3 and you multiply everything. So negative 3, 6x squared. Negative 3, negative 5x. And then lastly, negative 3 times the 2. So 1 by 1. And then you do multiplication. 24x cubed, 20x squared, 8x. And then the green one, negative 18x squared, positive 15x, and then minus 6. X squared, x and x, only these are like terms. So when you combine, you get the exact same result. 24x cubed negative 38x squared plus 23x and a single negative 6. I showed you both method. Whichever is easier, use that. Question? No? Then you try one by yourself and compare with your partners, with your neighbors. And remember, these are final exam questions. One definitely you'll see in the final exam, and definitely one of them you'll see in the in-class exam next week. Are you guys ready? Not yet. Ready? Okay, Melvin, help me with this. Which method you used? Distribution or box? Traditional, okay. So you distributed, right? So you take 8x squared and then you multiply to both of them. Okay. So 8x squared times 2x cubed plus 8x squared times 5x. And then you do the next term, did you? So negative 7x times 2x cubed negative 7x times the 5x. And lastly, the 3. We have 3 times 2x cubed and 3 times 5x. So what do you have in the first row? 16x to the 5th. Oh, you have 14 here. So minus 14x to the 4th. Okay. Plus 6x to the 3rd. Next. Plus, right? Plus 40x cubed minus 35x squared. 6? How did you get 6? It's 3 times 5x. 15x. Be careful. So that's why highlight like what you're multiplying. You're taking 8x and you're multiplying all of them. So you have to see 8x twice and you interact 2 times twice. And then highlight the next one and then multiply the next one. In that you'll see if you miss anything. So when you add all of these, the first term is 5x to the 5. Do you have any other 5 term?
No.
No. So you leave it alone. 16x to the 5.
There's no other 4 term.
There is no other 4 term. So negative 14x to the 4.
Plus 46x to the 6. That's the third.
Third. So for third, we have 2 terms. Lucky. So we have plus 46 x to the third. 15 is an x, but our next is x squared minus 35 x squared. And then 15x. So what do you think? It's too long, but it's a final lesson question. You are going to do them in the final. No, any question. They're not hard. It's just too many multiplications. Any question on the multiplication? Next, we are going to do the same thing, but instead of multiplying, we want to do the multiplication without doing multiplication. Okay? That's why we have special rules. Because we don't want to do multiplication. We want to save our time. So shortcut. Shortcut says if you multiply same binomial twice, exact same thing if you multiply twice, yes, you don't have to distribute and FOIL them out and then get the result. Because the result will be the first term squared plus the second term squared plus something extra. And that extra is twice their product. And if you subtract them, the same thing. The first one squared plus the second one squared, and this is minus something extra. And that extra is twice their product. So you don't have to multiply them to see the result. This is the result. And then what if you multiply, they look similar, but their signs are different. If you have the exact same two terms, only their middle signs are different, we call them conjugates. So these are, let me change color to something different. These are called conjugates. Conjugate means exact same two terms, only the middle signs are different. So when you multiply two conjugates, you don't have to multiply this, that. When you multiply them, the result is the first term squared minus the second term squared. That's it. So it saves a lot of time. And we can actually go backward. So these are called difference of perfect squares. So when they say factors, so the second one is for chapter 6, when you're going to do factoring. When it says factor difference of perfect squares, the factors for difference of perfect squares is you take the bases, you add them, you subtract them. So difference of perfect squares gives us two conjugates, and when you multiply two conjugates, you get difference of perfect squares. Again, if you don't remember any of this, if you have bad memory, your hope is distribution. But if you learn this, trust me, you're going to save a lot of time. So let's do one example. 6x plus 3 with a square. The rule says all you have to do is take the first term, square it, plus take your second term, square that. The first term square plus second term square. And then you're going to add something extra. We're going to add because we are adding here in the binomial. What is extra? It's 2 times their product, their individual products, which is 6x and 3. So you multiply them with 2 in the middle, and then the first one squared plus the second one squared. And then all you have to do is use your power rule to simplify. More base 1 power, what do we do? We distribute the power. So in here, we get 6 squared x squared. which is 36x squared. And in here we have three numbers here multiplying. 3 times 2 is 6. 6 times 6 is 6 times 6.
6.
And
Plus 9.
plus 9. That's it. Robert. You can do that, but this will save you time. Okay, then you try one. You can try both methods. You can try your distributing method if you didn't like the special formula. But once you're done with your distribution, then try the special formula. At least try it. You may end up liking it. And the rule says when you have minus, you subtract 2 times whatever you have. Done? What do you have? Tell me the answer, I'll tell you.
Huh?
Tell me the answer, what do you have?
First one?
Mhm.
25x.
Good, done. And then what do you have? Plus how many y's? Yeah, but here 2y whole thing square, right?
25x squared plus y plus 4y squared plus 20xy.
Something is definitely wrong.
Is it okay to multiply the variables for them?
Yeah, but if they're different, you just put them together. They have nothing to multiply.
So, since it's 5x and 2y, I put 20.
XY. Perfect.
I try to use the shortcut, but I don't know if I try to do the shortcut.
Okay, this one, right? So 25x squared and then plus 4y squared, perfect. And then 20x squared. Perfect.
Oh, that's it? Oh, word. I should check on it.
Then I can.
Because I have a meeting right now.
Okay, go ahead.
Uh,
Okay, so if you do shortcuts, all you have to do is put 5x whole thing square, 2y whole thing square, and then 2 times 5x and 2y. And then go ahead, Brianna, tell me the answer. What do you have?
One is 25 to the x to the second power.
25x squared.
And then it's going to be subtract, multiply 5 times 2
and -2 is gonna be -20xy
Negative 20xy
plus 4y,
plus 4y
y squared.
square. Let's do two more. We didn't have to use FOIL because the rule says all you have to do is take the first one square, always minus, take the second term square.
What's that?
So we have x squared minus 1.
And that would be the answer.
That's it. You don't have to use FOIL. You don't have to do FOIL. All you have to do is take your first term square. So your first term is x, square that, take your second term, square that, and always subtract. So square both quantity and then subtract them. Anything.
So you see how we did things different for B, you could do that for B.
So if you apply this rule, it's something square minus something square. Because you have the exact same two things, 4x plus 3, 4x minus 3. So what goes inside the first square? 4x. And the second square? Only 3. She doesn't have any x, right? Only 3. And now use your exponent rules.
16x to the second
16x squared
and -9.
minus 9. That's it.
So then what are we doing next?
More exponent rules. We are going to work with radicals, whole number, fraction power, negative powers, those. And once we are done with them, we have your exam.
And I have a question. If these like my lab, math homework, like, let's say I turn in an assignment after the due date, even though I'm gonna get my points, I would still turn it.
21.
5 times 2 is
10.
10 times 2,
10.
10. So numbers gives you 20. And then x times y, simply x, right?
What's the right answer?
Can I ask what the homework is for this week?
Okay, so tonight homework is 4.5 homework and quiz and 5.1 homework.
So like
Tonight.
one quiz? Okay.
2 homework, 1 quiz tonight.
What's your name, by the way? I have no idea who that would be there. Like, I don't know. It's like,
Bye. See you Thursday. 12:53 1 hour, 15 minutes. You're done?
As a question, the 3 points added after I give you it, or